All right, we have started chapter 7, section 1, the ellipse. It's an interesting little thing. An ellipse is one of the 4 conic sections that we study, and you can see here how they're found, how they're made. You take a cone and you run a plane through it, and it is a section of a cone. If you want to see the animated version, there is a YouTube video there you can see. The definition of an ellipse is a set of all points in a plane such that the distances from 2 fixed points, called the foci, is constant. So it sounds like a very strange definition, but if you want to see how you can make an ellipse pretty easily with a piece of string, you can look at the video that's put there for you. More than just that, what you really need to know is the vocabulary that's down here at the bottom of the page. You'll see that each ellipse has 2 vertices that are on the end of the major axis. The major axis is major because it's the bigger one, and the minor axis is the smaller one. And then, of course, the center is the center. And the foci are always located on the major axis. All right, and this is a horizontal one because the major axis is horizontal, and this is a vertical one because the major axis, the longer one, is vertical. The standard form of the equation of an ellipse centered at the origin. If your ellipse is at the origin, then you have either x squared over a squared plus y squared over b squared equals 1. Now this is the horizontal one. And then if it's vertical, you just change the a and the b. All right. The distance to the focus from the center is always this number c, and you can find c by using c squared equals a squared minus b squared, and that is how you can tell where c is. We'll do a few examples of that in this section. And then, of course, they use the Pythagorean theorem. You probably guessed that, only the letters switch a little bit. A is over here, B is here, and C is there at the base. So c squared equals a squared minus b squared. Using it. All right, now just looking at this equation, you can tell a lot of things about this ellipse. The first thing you can tell is that it's centered at 0, 0 because it's just x squared and y squared. Then you can tell it's horizontal because the 9 is bigger than the 4. So you know A is 3 and B is 2. So you can graph it really quickly. Just start at the center and then go 3 in the x direction, both ways, positive and negative 3, and then 2 in the y direction, both ways. And those are our 4 points that we are going to try to connect, at least I am, in an ellipse. I can try and make it ovally. That's not bad. So you can also tell where the foci are, because the foci are located c units away, and we know c squared equals a squared minus b squared, and in this case, c squared is 9 minus 4, so c squared is 5, so c is plus or minus square root 5, so the foci are it's horizontal, so plus or minus square root 5, 0. Easy peasy. This is an example of a vertical one. You can tell it's vertical because the 25 is bigger than the 16. And again, they found the foci here just by doing c squared equals 25 minus 16, so 9 equals c squared. So there's your plus or minus 3. All right. All right, now how can we do one if there's nothing given to us except the equation? Well, this one has a slight problem in that it's started not equal to 1. So let's first divide by 36. And then we get the nice equation x squared over 4 plus y squared over 9 equals 1. So we know this one has to be vertical because the 9 is bigger. We know that A is 3. We know B is 2. So we can go ahead and draw that out. It's centered at 0, 0 because it's got the x squared and the y squared. So we go 2 on the x and 3 on the y. And those are our 4 points. I'll try to do an ellipse. It doesn't look like a football. Kind of. So there's that. And then we can also find, again, this is 4 and 9. So we know that c squared equals 5. So c equals plus or minus square root 5 again with the 4 and the 9. And this one is going to be vertical though. So they're going to be at 0 plus or minus square root 5 because they're going to be vertical this time. All right. And you don't have to be exact on the foci if they're decimals when you're graphing them. You do have to be exact in the writing them, but graphing them, you just place them around where they should go. All right, so now we have this one. See if you can pause this and write the equation that this should be. All right, and it should, let's see, we've got 2 horizontally and we've got 4 vertically, and it's centered at 0, 0. So we know it should be x squared over 2 squared plus y squared over 4 squared equals 1, or simplify it a little bit, x squared over 4 plus y squared over 16 equals 1. And of course you can do that in one step if you like, just, you can tell by looking. All right. Translations of ellipses. Now this is moving it left and right and up and down. Let's see what's going to happen to our equation. Many of you probably already remember what happens with translations. All right, so if we move over and up, HK, that moves the vertex, we write it now as x minus h squared over a squared plus y minus k squared over b squared equals 1. And of course that's a horizontal. A vertical would switch the a and the b. So let's look at this one. X minus 1 squared over 4 plus y plus 2 squared over 9. So we have minus 1 and plus 2, so that gives us our center at 1, negative 2. And then we know it's vertical because the 9 is bigger, so we know A is 3 and B is 2. And of course we can just draw it out really quickly. If you start at the center and you go 2 each direction this way and 3 each direction that way vertically, then you have your lovely 4 points, and they make a much better ellipse than I do. All right, let's graph this one. X plus 2 quantity squared over 9 plus y minus 1 quantity squared over 4 equals 1. So let's start by identifying some of the things about it. Where's its center now? So we've got plus 2 minus 1. So the center would be at negative 2, positive 1. And then we have to say, well, which way is this? Well, this one's horizontal because the 9 is bigger. And A is 3 and B is 2. So let's start our graph. We move to the center first. Negative 2, 1. put your center in, and then you just count off whatever A and B are. A is 3, 1, 2, 3, and B is 1, 2, 3. Sorry, 1, 2, 3. Get my other one, and then B is 2. Count that off. 1, 2, 1, 2. We have our 4 points, and I'm going to attempt to make an ellipse again. And it's kind of football-y, but there. Okay, now where are the foci? Well, we know that relationship for the foci, c squared equals a squared minus b squared. So again, we're at that plus or minus square root of 5, but it's from the center this time, so it's going to be plus or minus square root of 5 from there. So we just write it out as negative 2 plus or minus the square root of 5, 1. And that you don't have to do the two numbers because the square root of 5 is some lovely decimal. But for the vertices and the endpoints of the minor axis, these 4 points, we do have to come up with the actual points. So those would be at negative 5, 1, 1, 1, and negative 2, negative 1, and negative 2, 3.